in the audience knows the command kubectl auth who am I? Because it's not the CANI, as I just found out. Those are different. Because here's a contributor to the Kubernetes SIG auth, and you also are a maintainer of the DEX project. And you're going to talk about the heroics of platform engineering, I guess. DaemonSet. Why should you care? Maksim Nabokikh.
You did the poll. Yeah.
Okay. Big applause for this talk.
Hello, survivors! Just wanted to shake you up for a little bit, sorry. Yeah. So my name is Maksim, and today we'll be talking about daemon sets, what is wrong with them, and why we should care about the problems. I work for the company called Pelark. This is the advertisement time. So we are DevOps and SRE experts. We have a lot of expertise with Kubernetes and especially with daemon sets. So if you have Kubernetes-related problem, we can help you with this. We are based in Germany. We have many awesome engineers and satisfied customers, managed Kubernetes, like all these things. So the plan for today's talk. At first, we, with our little engineers in the audience, will revise just one more time what is daemon set and which workloads are daemon sets. And finally, we will talk about problems and a little bit about solutions, but not for all of the problems. Okay, if we want to deploy a pod in Kubernetes, we usually use a controller. We don't do it manually. And there are three main controllers: deployments, stateful sets, and daemon sets. Deployment we use to deploy X replicas on Y nodes. Stateful set we basically use for the same purpose, but with additional features like persistent volume, static names, and discovery features, these things. And daemon set we use when we want to deploy replica of our software on each node. And if you're a user of Kubernetes platform, you probably mostly interact with these two controllers. But if you're a platform engineer, you should care about daemon sets, because daemon sets, they are our main weapon as platform engineers. When we create a daemon set controller comes to an action, and what it does. So it counts desired node based on node selector, tolerations, and affinity. This is all the part of the spec of the daemon set. Then it deploys a pod on each node as we want it, right? And then the most important part, not important but interesting part, is that these pods, they tolerate some taints by default. So for example, pit pressure, disk pressure, memory pressure. So daemon set pods, they do not care about resource problems. They also by default tolerate unreachable, unschedulable, and not ready nodes. So we will deploy pods anyway to these nodes. And if the network is not available and the daemon set is in host network, we will also tolerate this. So this is not a problem for daemon set pods. Yeah, some nuances about how daemon set controller works and the flowchart. We have three nodes, different labels on them. Two labeled as production environment, and this third one is labeled as development environment. So we create a daemon set with node selector, and our controller creates pods on the nodes. Pretty simple, right? Which workloads we run as daemon sets? First of all, CNI, kubeproxy, and other network add-ons. We want to prepare a network on all the nodes in the cluster, so we use daemon sets for this case. CSI drivers, so the part of the CSI driver is the tool that we run on each node to attach and detach volumes. Node local DNS, so this is a DNS cache to make our DNS requests more efficient and reliable. And observability add-ons such as exporters like Node Exporter, log collectors such as FluentBit or Vector, security scanners like Falco, and third-party agents like Datadog agent, Dynatrace agent, and all these agents. Yeah, there's also one special case when we use daemon sets. Is when we want to run software on each node. For example, if we have a dedicated node pool for ingress traffic, we want to run ingress pod on each ingress node, and we don't want to like add the node and scale the controller. Yeah, we want to do it automatically when the node is added. So we want to be sure that ingress controller is deployed on this node. So this is kind of special case. Okay, it was all about daemon sets. So let's move to the problems straight away. The first problem is resources consumption. Imagine we have two nodes and two different applications running on them. So the application 1 and application 2. And we also have log collector pods that collect logs, right? This application, they're different and they produce different amount of logs. So the first one produces 1 megabytes per second, and the second produces 50 megabytes per second. So log collectors spend different resources to process these logs. The first log collector spends 50 milli-CPU for the task, and the second log collector pod spends the whole core of the CPU to process these logs. But this log collector, these both pods is a single daemon set. And my question is, which resources request do I need to set for this daemon set? Because as we've seen before, like the consumption is different, yeah? Solution number 1, so we can undersell. So we can set the request to the higher consumption of the, among the all pods of the daemon set, and in this case, we will just be paying more for the infra, yeah, because we are underselling. We can oversell we can set requests to like the average number among all the daemon set pods, but there will be always a risk of resources pressure. So we probably don't want resources pressure because we want our system to be reliable. The interesting one, we can use different daemon sets for different node pools. For example, we know that the application 1 and application 2, we know that they're different. We may deploy different daemon sets for these nodes, but it's completely unmanageable and overcomplicated. And if you have a dedicated platform team, engineers will never agree for this. They will not do this. And the fourth point, maybe we can use VPA. What is VPA? So VPA is vertical pod autoscaler. And it can apply resources request dynamically based on the real consumption of your pods in the cluster. Sounds pretty cool, right? Sounds what we want in this case. Let's just revise how VPA works. So VPA has 3 parts: controller, evictor, and webhook. So there is a pod in the cluster, and controller watches resources consumption through metrics API, and then writes expected requests for the pod. When the consumption grows, controller updates expected requests to the new value, and then evictor comes to an action. So evictor sees there is a difference between expected requests and real world consumption. So it evicts the pod, and the new pod is created. And this is when admission webhook comes to an action. So admission webhook checks the expected request and set request to the new pod. And this is how VPA works. But there are a lot of sad moments in this. The first sad moment is VPA count resources per controller and not per node. So it doesn't help us with our resources consumption problem. There is an issue opened in 2023, still not solved and not answered in VPA report. So pretty sad thing. Okay, the second sad thing is that eviction hurts. So you don't want to evict any pod of the daemon set, for example, not local DNS. So under the load, you don't want to evict all your cache from the cluster because it's just pointless, right? There is a special cab in Kubernetes to fix this issue as well. So the in-place update for resources of pods, it's in alpha stage now, but so you can stop evicting your pods. You can just in place update your resources request. This is cool, but still not supported in VPA and still in alpha. And VPA also cannot count living replicas of daemon sets, so it can evict all daemon set pods at once, just like in a single minute. Also a problem, but this one we fixed with our pull request, so it's now it's fixed. Yeah, this is now okay. Maybe PDB can help us with eviction of DaemonSet pods. Yeah, PDB stands for like a pod disruption budget, and we can state with the PDB how many replicas may be unavailable at a time for a specific like label selector. But sadly, we cannot use it with DaemonSets as well. And there is an issue in Kubernetes. Kubernetes also cannot count living replicas of DaemonSets. We opened this issue back in 2022. It was considered as a new feature, then considered as a bug, and we have a proper solution, a minimalistic solution, and the problem is still not fixed. So PDB also doesn't work with the DaemonSet. Okay, no solution. Let's move forward to the second problem. And the second problem is taints and tolerations. If we want to dedicate a node for specific workloads, we usually use taints, right? So we can set a dedicated production taint to specific nodes. And then in our production pods controllers, we can tolerate this taint with the following toleration. Cool, right? But what with DaemonSets? So DaemonSets, we want to deploy network plugins on all the nodes of the cluster light, otherwise the nodes will not work. So DaemonSet, they need to tolerate these special dedicated taints. How to tolerate everything? Every possible taint. There is a special toleration operator exists. With this, we can tolerate pretty much any taints on any nodes. But do we want to tolerate everything? No. Of course not, because there are special cases. The first one is network unavailable, and the second one is cloud provider uninitialized taint. So these two taints that show us that network for the node, so node was registered, but the network is not ready yet. And then if we deploy a pod to this node, they probably will fail to start because of unavailability of some network connections for these pods. We found this problem in one of our clusters, and so it took us 2 more minutes to provision node in this cluster just because we deployed pods to nodes with not ready network. Also CSI not ready taints, if you have one, so there is no CSI not ready taints in Kubernetes, but just my imagination, yes. So if CSI is not ready, you don't want to deploy any volumes, any pods with persistent volumes, and maybe some other taints. Yes, there are some pieces of software that uses taints for eviction or for other purposes, so we don't want to tolerate them at once. The solution for this problem, as we solved it, I'm just sharing our solution with you, and we ignore keys. Not all the taints, but specific keys. So you can tolerate a specific key with the following toleration. You need to specify key and operator, and either it will be example com prod or example com def. We will tolerate this all these taints. Yeah, and then we just auto-generate tolerations for our daemon sets from the set of keys that our clients provide to us. So we don't use operator exist tolerations for our daemon sets. Yeah, so for us it works a lot better when we used it. Okay, and the third problem is rolling update. In normal case, rolling update works like this. There is a pod, there is a new version of the pod, so we start creating a new pod, and the old one is still running, so when the new one is running, we kill the old one, and we have a brand new replica of our application. But DaemonSet rolling update usually works like this, because we usually use daemon sets with the host network and bind them to some host network ports. And when we start a new pod, the new version of our software is waiting for the port to be available, and it's waiting and waiting and waiting, and yeah, nothing happens, right? So it doesn't work. Impossible to use rolling update in most cases, because more than half of our daemon sets, they are running in host network. So cannot use rolling update with this. But is little unavailability bad? Maybe we can use just like not use rolling update, and then instead use what? Instead of use just like a normal update. No rolling update case, how it works. So there is a pod with the software. We kill this pod, and then we create the pod with a new version of our software. And this is the problematic moment. Only there, Kubernetes starts downloading the image for this container. And if you run, for example, Cilium, which is pretty big, pretty big image, or if you run, I don't know, maybe the internet connection in your cluster is poor, so it can take ages between these two stages, between this one and this one. So there can be an outage. Can we maybe do canary? So like instead of working with updating a single daemon set, maybe we can just create a new one and forget about the old one, as Kubernetes documentation suggests us do for deployment. Sadly, we cannot, because we cannot scale daemon set from a single node to another easily, yes, because daemon set controller calculates the nodes we run in pods. We discussed it previously, yeah. So canary we also cannot do with ordinary daemon set in Kubernetes. Solutions for this problem. You may write your own controller. Yeah, I cannot stop you. Or you can use one of already written controllers. There are some controllers that solves problems. The first one is OpenKruise, and the second one I found Datadog DaemonSet, but there are probably more of them on the internet. And let's talk a little bit about this solution. So OpenKruise is CNCF incubating products. And it solves a lot of DaemonSet issues, like it can pre-download the image to your node. So in the moment of restart, you already have the image. Pretty cool feature. It can also do canary. But sadly, OpenKruise is cumbersome. There is not only DaemonSet controller, but there are different controllers for like advanced deployment, advanced DaemonSet, and there are many moving parts in this OpenKruise. So it's, if you only want to fix DaemonSet controllers, it can be an overkill for your infrastructure. Yeah, and Datadog DaemonSet, it solves the canary problem, but it has many limitations. I can just suggest you to see how they solve the problem, how they write the controller, and then write your own. But maybe this is the one controller you need to fix your DaemonSet problem. Who knows? Yeah. So you can use Datadog DaemonSet controller as well to fix this issue. Yeah, and that was it. Let's just summarize what we've been talking about today. And yeah, so the first point is DaemonSet is platform engineers' fine weapon. So if you're running a platform, you should care about your daemon sets. And probably this is the thing that causes your platform a lot of pain. Okay, it has many problems, but some have workarounds. And some will be fixed in the future, because I believe in our community, someday we will fix them. Because we already identified them, and this is half of the job done already. Before reinventing the wheel, just check out existing solutions. And maybe there is something that already solves your daemon set problem. And that was it. Be careful with daemon sets. Thank you so much.
Wow, and that was 150 slides.
Yeah, I can prove.
Thank you so much. Questions for Maksim? Yes. Please speak.
Sorry. Please repeat the question.
Okay. So at the beginning, you mentioned that daemon sets should be ideally deployed through controllers. What is the rationale behind that?
So maybe I didn't state it clear, but I don't know to I don't want to dive deep into Kubernetes, but there are like resources in Kubernetes, like daemon sets, and they are like provisioned by a Kubernetes controller manager, and daemon set controller is a part of kube controller manager. So what I meant by this is like there is a controller in Kubernetes that works with the daemon set objects. So you don't need to write your own controller. This is already inside the Kubernetes. That's what I meant.
Did that answer the question? Yeah. Thanks. There's another question over there. Maybe if you can speak loud, or the microphone is coming, we have time. So.
You said that with the image pull there is an issue, but you could also just pre-download the image on all nodes, right?
Yeah, but how can you do this? Yeah, with OpenKruise, of course.
Well, just create a daemon set with pause entry point, and that way you download the image.
You sound like a good platform engineer.
It's a hacky workaround.
Yeah, I agree. So this is what I meant by writing your own controllers or your own solutions. This is one of these things. Yeah. So you can, of course, fix the problem. There are scripts and daemon sets with what you've said. There are examples on GitHub, and we can always do this. But I myself personally want this problem to be solved in Kubernetes, not with some hacky workarounds. Yeah. So ideally, yeah, we can work with this, we can live with this, but ideally it should be solved in Kubernetes as well.
Do you have a solution for daemon jobs as well?
I personally never use daemon jobs, so I don't know. Cannot answer the question properly because didn't have a chance to dive deep enough.
I think there are no further questions.
Yeah. You can just stand up and say, yeah, I have the same pain as you.
So maybe a question here. So where did the pain start? Because usually there's the breaking point. You know, you deal with stuff, and then there's the point like, I want to change something. Do you?
I think when you just have an idea to develop your own Kubernetes platform, the world is bright and shiny with all the flowers blooming. But when you develop it for a year and next 2 years, 3 years, 5 years, you start facing these complicated problems that you've never thought about before. Yeah.
All right. Well, thank you so much, Maksim. Big applause for the
Thank you for listening.